Now that you have retrieved the data about the routes that are assigned to you, what you can do is you can start analyzing this data. Suppose you're interested in finding the relationship between departure delays and arrival delays. In other words, are arrival delays mainly due to departure delays, or are there other things other than departure delays that cause arrival delays? Okay, so for example, here there was a 40-minute delay in departure. Okay, the plane departed 40 minutes late, but it arrived more than 40 minutes late. It arrived 75 minutes late. So now you want to have a better idea about what is going on between departure delays and arrival delays. For that, we can draw a scatter plot and add a trend line. So what I do is I click here, hold down Shift and Control, right arrow, hold down Shift and Control, down arrow. Okay, so I have selected these two columns, and I'm going to click on Insert, and I'm going to select Scatter Plot, and I'm going to click here. Okay, Scatter Plot. And when I do that, I'll see something like that, like this, appear on my screen. Okay, so it says arrival delay. Now I'd like to declutter this a bit, so I'm going to click on the legend, press delete. I'm going to click on one of these parallel lines, okay, and then I'm going to delete them. So now I have something that looks like this, but you see the the axes pass through the data points, so I don't like that. So what I want to do is I want to take this horizontal axis and move it to minus 100. Okay, so I right click on any of these numbers, 300, 250, 200, etc. When you right click, it'll give you this pop-up menu, and you want to select Format Axis. And in this dialog box, you want to say, okay, horizontal axis crosses at minus 100, and then enter. Okay, so now I have moved down the horizontal axis. Now I want to move the vertical axis. So I right click on any of the numbers on the horizontal axis, Format Axis, and here I want the axis value at minus 50. Close or press enter. Okay, so now I have a better looking graph. Okay, so the horizontal axis shows the departure delays, and the vertical axis shows the arrival delays. Okay, so there seems to be a relationship between these two. Now I can fit a regression line or a trend line, and Excel gives you many options. Okay, so to add a trend line, I'm going to right click on any data point, and I'm going to select Add Trend Line. Okay, now I have several options. Okay, the first option says linear, and I want to, and I'm just going to say okay. So I have a straight line, which is my trend line. Okay, so that looks good, but let me try different options. Maybe I'll get a better fitting line. So I right click again on any data point, and I say Add Trend Line. Now logarithmic will not be possible because we have negative values. I say okay. And then I right click, add trend line. Let me select polynomial. Okay. And then I say close. Now I have a polynomial line which is the curved line, but it's very, very close to the straight line. So I want to delete the curved line. So I select that and I press delete. So now I'm down to the straight line. I select that. Okay, I select the straight line and I go to format trend line because I want to see the equation on chart and the R-square value. Okay, so I select display equation on chart and I select display R-square on the chart. Okay, I click OK. So then I get this text box. Now it gives me information about this trend line. Okay, so R-square is 0.8112. Okay, so what does that mean? It simply means 81% of the arrival delays can be explained by departure delays. Okay, so that means about 21% or 19%, I'm sorry, 19% of arrival delays cannot be explained by departure delays. So 19% of arrival delays must be related to something other than a late departure. Okay, so what else does this text box tell me? It gives me a regression equation. Okay, so it says y equals, now y is my departure delay, x is my y is the arrival delay, x is the departure delay. Okay, so now when x equals 0, when I have no departure delay, this term will be 0, but I will still have this term, okay, minus 4.29 something. So what this equation tells me is that arrival delay y will equal minus 4.29 something when departure delay is 0. If I depart on time, I will arrive on average 4.29 minutes early. Okay, so this is what this minus 2.49 something means. Now what about this 1.0623? Okay, it also has an interesting interpretation. So if my delay, departure delay, increases by 1 minute, okay, my arrival delay will increase by 1.0623 minutes. In other words, every minute of departure delay will be magnified, and the arrival delay will be greater than the departure delay. Okay, so how much larger of an arrival delay will I have? I will have 6% more arrival delay in terms of departure delay. Okay, so whatever my departure delay is, my arrival delay will be 6% more. Okay, so this is how to interpret this equation and this value.